잠시 후면 산업용 로봇 컨퍼런스를 진행하도록 하겠습니다. 첫 강연 순서로는
Mr. Sonuki of Mission Oriented Innovation Forum will be the first speaker. And Mr. Kim, please let us know if you're ready. And you may begin your presentation as soon you are ready to do so.
안녕하세요.
Good afternoon, ladies and gentlemen. Would it be alright for me to begin? Since we don't have much audience, it doesn't feel as though I am making a presentation in front of an audience. I've been given about half an hour, and so I will talk for the next half an hour. The topic of my presentation, or the title of my presentation, is called Sustainable Development and Mission-Oriented Robotics. And the organizer has asked me to prepare the materials in English. That is why my presentation material is in English. About 2 years ago, I think I made this presentation with a very similar theme about 2 years ago at this very conference. Robotic technology has advanced since then, and at that time I was talking about the fourth industrial revolution. And now we talk about sustainable development and carbon neutrality. And they have become very important issues. And Korea has become very much interested in such issues, as I said, in carbon neutrality and other sustainable development. Before I talk about sustainable development, I think I need to talk about the challenges that are faced by a human race. Well, this is an international conference, and that is why I have prepared my materials in English and have brought in news articles in English. So you see them here on the screen. And Mezgato, who is an economist, has written this article last year. And in this article, she talks about capitalism's triple crisis. We've had economic crisis before. We've had economic stagnation before. And we've also had a climate crisis before. It's been an issue for the past 2 decades or so. And since last year, we have had an added crisis called the infectious disease crisis. And these three crises, the sources of these crises are interconnected. And to resolve these crises, well, we need to find solutions together, solutions that is applicable to all three crises. So we have to find ways to overcome the economic difficulties as well as the climate crisis and pandemic on top of it. And this is something that I often refer to as I talk about the climate crisis. You may have seen this movie, Endgame of Avengers. And here the Thanos here is trying to reduce the population by half. And according to some, he's trying to reduce climate crisis by reducing population. And related to climate crisis, well, the universe is so wide, so broad. Why haven't we been able to find other intelligent beings? And according to a professor at Harvard University, rather than find live, intelligent beings, it would be easier for us to find the beings that used to be, but that is no longer with us. And this is related to this thesis called the Great Filter. The Earth came to be about 4 billion years ago, and people began. There was evolution, from molecular cells. From monocells to multiple cells. And so there was, however, there was a filter that stopped the evolution. And climate crisis could be one of those filters that put stops to a continued evolution or continued development. And one of the reasons that we are not able to find live beings in the universe is because of this great filter. This is Mr. Andrew Yang. He was one of the Democratic candidate for presidency. One of his commitment was to introduce issues related to solving problems related to climate. And he talks about geoengineering proposals. Well, because the CO2 concentration is high in the atmosphere that is causing the climate crisis. And to resolve that issue, he is suggesting very dramatic or extreme measures, and such as artificially growing the planktons in the sea to observe the carbons. So he was talking about artificial intervention of the climate, and that's what he was asserting for. that he was asserting that the geoengineering should be done. And actually, Bill Gates is also asserting that geoengineering should be done. So Bill Gates and Andrew Yang, they talk about geoengineering. And because the extreme crisis that we face because of the climate changes. And well, that with the geoengineering, we may be able to stop the emission of CO2s. However, there are already CO2s in the atmosphere that have been accumulated. Even if we no longer do the emission, but that's not going to stop us, stop the temperature from increasing. Well, anyway, Microsoft is talking about a carbon negative. We talk about carbon neutrality. We talk about carbon neutrality by 2050, but actually this company talks about carbon negative by 2030. So the company goes one step further when it comes to carbon reduction. And by 2050, Microsoft will remove from the environment all the carbon the company has emitted either directly or electrical consumption since it was founded in 1975. Well, Microsoft Office and other programs are now provided in the form of SaaS, because those products are in the cloud. But they were provided in the past in CDs, and in the manufacturing of the CDs, a lot of carbons were emitted. And so Microsoft is saying that it's going to take care of, to remove all those carbons that have emitted in the process of, for instance, production of CDs. I talked about, and then this inequality. What this is, Oxfam and other organizations have been issuing reports about the critical issue of inequality. And according to one organization, by 2019, world billionaires had more wealth than 4.6 billion people. And it also says that combined wealth of the world's 22 richest men is more than the wealth of all the women in Africa. And there could be many reasons for inequality, and automation is could be one of the reasons. In robots, there is a scholar called Hans Morabach. He said that. Well, he was referring to a great flood, and when there's a flood, people move to the top of the mountain. And same with the computers, with the advancement of the computer performance, and that is almost like a flooding. And so in the past, the task that only people could do can be done now. Computers, and because of that, people have to go higher and higher, and as a result, they will go to the top of the mountain. And at the top of the mountain, they will have to make something like an ark to be able to evacuate themselves. So that's what he was referring to when he was talking about the Great Flood. And then now I want to talk about automation and utopia. You're at the Robot Conference here today, and I think we need to talk about utopia-like potential of automation. If we could use the robots well, then people can be free from the work that they don't want to do, and people can just focus on doing the work that they want to do. And so that's what I would like to talk about here. This is a British philosopher, and in his book last year, he talks about the book is entitled "Automation and Utopia," and the subtitle is "Human Flourishing in a World Without Work." I've not read the book. I mean, I have the book, but I have not read it. And according to this book, as people evolve, people could become cyborg, and people will be merged with machines and become like half human and half machine. And we talk about the metaverse, and so with the expansion of the metaverse, more of our lives will take place in metaverse. And so this person is saying that it would be more like a utopia for people to live in a world that is more like a metaverse than the real world. And then there is this book called The Zero Marginal Cost Society by Rifkin. And this talks the marginal cost of producing each additional item falls to essentially nothing, according to this the author. Then everything will becomes free. And in case of software, the marginal cost is almost zero. Microsoft Word, I mean, it could take billions to do the development initially, but because it's a software, the delivery costs nothing because you don't need CDs like as in the past. And so in the software, the marginal cost may be zero, but in other economic areas, industry fields, the marginal cost will also will become zero, which means that capitalism will take completely a different form. And then this person from Great Britain, it talks about capitalism in the age of robots, work, income, and wealth in the 21st century. And in, let's say, 2100, the robot that is operated by a solar, that is a photovoltaic light with AI, the energy will come from the sun, so the energy will cost almost nothing. And these robots will be able to produce all the things that people in the world, that is a billion people, need. Then the cost will be almost nothing because it will be robots doing the work. The production will be doing all the work, and the PV plant will be operated by robots, and the robots will be maintaining the robots, and they use renewable energy on top of it. And then and with that, the cost will come down to nothing. And so the economic size will decrease, and the GDP size will become so small. And does that mean that economy will disappear? No, that's not the case. But the concept of productivity and GDP, the main principles of economics will go away, according to this author of this book. And this is one of the examples that I give whenever I give talks, and that is a lunar-based, self-replicating solar factory. This is a very interesting idea. And so a self-replicating system, that this could be self-replicating robot. We don't have them right now, but in 3 decades or 5 decades, we may have a self-replicating robot, and we could send it to the moon, and that robot could use the resources on the moon to continue to replicate itself. And there will be many robots on the moon, and they will make things such as the solar panels, and will send back to the Earth. And then we will have so-called universal solar energy, which will give people on Earth a lot of energy. And that's almost like a utopian story. And so when you think about this, the total cost, it's only for the one robot, R&D cost and the cost of sending the robot to the moon. So and then it was up to the robot to use the resources available on the moon and to do the self-replication. And so this shows excellent potential of the robots. I don't have a clock here, so I don't know how much time I've spent. Half an hour, 15 minutes, so I think I need to hurry through. So people talk about utopia. There is a person by the name of Sam Altman, who is a famous accelerator. And he, a few years ago, with Elon Musk, they have created non-profit AI model. And last year, it received funding of about $1 billion from Microsoft. And so that Microsoft will be able to use the technology from this open AI. And Mr. Altman said that in his blog that there will be a Moore's law for everything. And given his experiences, he sees that AI is going to be almost revolutionary, and so that the cost of all the labor will become zero. So there will be smart robots, and the value of the people's work will become zero, because we will have AIs and robots that can work better than people. Then we would need, a safety network such as like a basic income. So we would need a social reform and to allow for equal or more appropriate distribution of wealth. And so that could potentially bring about a democracy for everyone. And well, that's according to Mr. Sam Altman anyway. Now, I talked about the challenges faced by human race, and then I talked about potentials that robots could potentially bring about. And now I'd like to briefly talk about sustainable development. President Moon Jae-in, at his address to the United Nations General Assembly, he talked about SDGs. And so there's SDG were announced in 2015 by the United Nations, and these are goals that are to be obtained by the world, and these goals are to be achieved by 2030. One of the goals is to get rid of poverty and famine, and also to ensure education for everyone. So there are 17 SDG goals that you see on the slide. And in order to obtain the SDGs, technology would be very important. So we would need technological revolution. We talk about the fourth industrial revolution and others. And according to a scholar called Parrott, or in his book called Technological Revolution and Financial Capital, he says that, according to his analysis of technological revolution of the past several hundreds of years, the revolution could be broken into installation period and adjustment period and the deployment period. And during the installation period, there's going to be a lot of excitement, for the technology, and there will be investment by the financial institutions, which is going to lead the bubbles, and then the bubble is sometime going to break, and that's going to bring about economic downturn, and then the technological potential is going to be merged into the industry, applied in the industry, and thereby improve the overall quality of life. And this can be seen from many other examples of technological revolution, from the canals to railways. And so the ICT revolution, which began in 1970 and 80, is still ongoing according to Parrott. And the ICT revolution is ongoing for almost 4 decades or 5 decades. Of course, there was a bubble that was established. I think it was back in 2000, and then the bubble broke. And then back in 2007, there was the great financial crisis, which once again broke the bubble. And so we've gone through the economic downturn. And so we are now still at this transition period or adjustment period. And during the adjustment period, the roles of the government is very important. The government actively needs to make active investment into the infrastructure along with the private sector in order to be able to build or to bring in the golden age. Well, that is according to the analysis that he's done of all the technological revolutions of the past since the Great Depression. And there were policies to bring about the welfare society, and there were about 20 and 30 years of a golden age of capitalism after the First World War. And for us to have a golden era of ICT, where we need to have investments, and we need to have a growth such as smart green growth. As we talk about sustainable development, well, that's all about carbon neutrality, about the green growth, and the fact that we have to do this smart, which means that we have to make a good use of ICT. So smart green growth is about bringing about growth using ICT, and to do this, what would we need? Well, I talked about the triple crisis. Well, there's something called mission-oriented innovation, and so R&D is not just for the sake of R&D. The R&D is there for in order to obtain missions, in order to resolve the great challenges faced by the humanity, and that's and so, in this time of transition or adjustment, the government, the public sector need to cooperate actively with the private sector to invest in the infrastructure so have sustainably developing economy. And these challenges. One of the challenges is to have a clean ocean, and for that we would have to come up with a mission, and that mission could be a plastic-free ocean, and that in order to set that mission, where we would need many multidisciplinary R&D projects. So here now we're talking about the technology, we're talking about the social science and others. So there has to be a multidisciplinary approach in order to achieve the missions set forth, in order to obtain the ultimate goal of green growth. And so we need to have a research and innovation projects. And lastly, I want to talk about mission-oriented robotics and sustainable development. Mission-oriented robotics, it's a phrase that I came up with myself. Well, there's a mission-oriented innovation. And we could also have mission-oriented robotics. And so let me give you an example of what this means. There is a nonprofit organization called the Robotics for Good, and it is an organization to achieve the goals of SDG, and it is trying to come up with the robotic solutions to help achieve the SDG goals. So there are young people working in this organization to come up with the technology and to come up with the support. How much time? Is it almost time? Can somebody tell me how much time I have left? How much time do I have? 5 minutes? 7 minutes? And so there are 17 SDGs. Of those, so for per SDG, I want to talk about potential contributions that can be made by robots related to poverty in all areas. All types of poverty needs to be eliminated. So extreme poverty has to be eradicated. And so people in this extreme poverty need to be lifted out of that extreme poverty. And so that's one of the goals. Well, this is according to Oxfam. Women or children, they don't have access to the basics, which means that they have to travel long distance just to get water, which means that women and young children are not able to get the education that they need in order to be able to build wealth. And so maybe you think this is too much. There's something called Molly robotics. And in 2015, 2016, Molly Robotic came up with this video that deals with chef robots. And recently, this organization introduced about $340,000 worth of robotic kitchen. And if such kitchen, thanks to Moore's law, becomes very, very cheap, then women and children could be freed or liberated from housework and thereby focus on things that can help them to achieve wealth. And then second is related to famine, how to eradicate hunger. So the food safety has to be improved, and the nutrition has to be ensured, and there has to be sustainable agriculture. When agriculture has a significant impact on the environment, and so if there is a sustainable agriculture that can provide food and nutrition for everyone, then people will be able to, everybody will be able to be free from famine. And food industry that I'm talking about here is agriculture, the processing, as well as delivery to consumers. There could be agricultural robots. There could be robots in the factories, as well as cooking robots. And if they could all help these processes to become automated, and they could help to eradicate hunger. And then stage 3 is health and well-being. And you see the countries with dark colors. Those are the countries has long longevity. But if you see Africa, the color is very light. So there is a health inequality that exists. And Da Vinci, the robot, a surgical robot. And then there was this article about the outlook of the robotic surgery. Many companies are entering into this field of robotic surgery, and because of the AI development, well, now the Da Vinci robot is very expensive because it's exclusive. But as I said, with more technology available, more accessible, and therefore cheaper, then more surgical robots will become available, which will thereby contribute to health and well-being. And then there's a quality education. And if you could use a telepresence robot, then we can provide more education to more people. And so here, trying to map robot to SDGs. What I'm presenting may not be 100% aligned or correlated, but I'm just throwing out the examples. And then SDG 7 is related to affordable and clean energy. And here, clean energy has to be provided to everyone. And that is what it's trying to do with SDG 7. And globally, the low carbon energy source access has to be ensured in order to have affordable and clean energy. And the advanced economies have better access to the low carbon energy. And so how to make renewable energy accessible to everyone. And the solar energy could help with that. And with the solar energy, if we do have, in order to be able to have large PV farms, we would need installation robots as well as the maintenance robots, and they would help to reduce the cost. And the 11 is related to sustainable cities and communities. And this is about, give you an example here. So cities account for about 30 to 40% of global emissions. But the cities are so important because by 2050, as compared to the current 60% of urbanization. By 2050, the urbanization will be about 90%, which means that we need to sustainable cities in order to bring about carbon neutrality and reduce impact on climate change, and especially the built environment. If we could bring about sustainability in architecture, that is a built environment, we could use a modular construction or the modular architecture technology, which would have the robots in factories produce the modules that go into the buildings and have those modules assembled at site. And with that, it would be, and because of that, it would ensure sustainability. And the overall construction period could be reduced because the modules are produced in plants. There could be a standardization. And so it would be like a container house. People could think that this is container houses, but technology is growing, and so that the 50 stories high buildings could be built with the modular building technology. So how much time? So I think I need to wrap up the presentation. And then there's SDG 12, and that is responsible consumption and production. And this is about the circular economy. With the EVs, they have to be batteries, and those the used battery need to be recycled. And the solar panels has a life cycle of about 30 years, so the 40 years. And once they come to the end of their life, they need to be recycled and reused, and that's a social issue. And then the waste that are thrown away by, for instance, large cities are usually, sent to smaller cities or the rural areas to other countries. So which means, but those cities or the regions do not want the wastes, and so the wastes have nowhere to go. And so AI could help, or the robotics could help with the handling of those wastes. And with the AMP, it would be robotics. It would be possible to sort out the waste, because people have to do this, and this could be quite costly because we have to think about the people's labor, and that sorting is expensive, and that is why the wastes are they just go into the incinerator or to landfills. And so if it could have, relatively cheap, the recycling robots, and they could help with the waste issue. And SDG 15 is related to life on land. And this is related to life on Earth. I mean, the example could be a robot that is planting trees. And in order to effectively respond to climate change, we need to plant a lot of trees, because trees, as you know, could absorb the carbons. And so these robots could help, definitely. And then lastly, let me briefly talk about the avatars. Avatar robots with avatars. I talked about the telepresence robot briefly, and so telepresence robot is avatar, so remotely, or the operator who remotely will be operating the robots, and that is why we call avatar robots. MIT Technology Review dealt with this issue in an article a few years ago, and according to the article, avatar could help workers in low-income countries to be free from dire work or difficult work. But however, to do that, we would need better networks. We would need, the network without latencies. So let's say Bangalore of India. We would need, for instance, we would like a diameter of like 500 kilometers. It would be possible to do an avatar economy. And Trump was going to build a wall, but then he didn't. But if there's a wall between Mexico and the US in the future, and there are no immigration, according to this movie, the Mexican workers will work in centers, in plants nearby the wall to be able to operate the avatars who are workers at homes of the U.S. Citizens. And then, there was this organization that was saying that it was going to send avatars to the moon or to the Mars instead of people. So if we could well use the robots, it would be possible for us to achieve the SDG goals and be able to open an era of the universe. This concludes my presentation. Thank you.
있습니다. 다음 순서로는
So we'll move on to the second presentation that will be presented by Director Kim Sun-woo of Mobius. And if you are ready, please start your presentation.
안녕하세요.
Good afternoon. I am Kim Sun-woo from Mobius Value Chain. Nice to meet you today. Well, we do not have the much turnout. Was less than expected, but even so, thank you very much for participation despite COVID situation. But even without this COVID situation, people tend to sit in the back, and we have lots of empty seats in front. Anyway, let me start my presentation. And previous speaker Kim Sun-woo has the same name with me. My name is Kim Sun-woo as well. He talked about utopia, and with the robot development, human's life will be improved. That's what he said in the presentation. But myself, let me talk about from the realistic perspective, not utopian perspective. Well, many elementary technologies have been developed for robotics, like vision sensing and deep learning and so on. And I could realize that technology has been developed, but to realize utopia, what should we do? Well, rather than using the booth outside, we have to make sure that this technology can be applied to the industrial side. So let me talk about the application methodology of the technologies. Well, for consulting and for e-business, many people are talking about logistics robots. And I am involved with this logistics robots, and I thought a lot how to apply these robots to the companies. First of all, we have to change the paradigm. Well, in the past, we achieved innovation and we achieved optimization. However, the past winning formula, well, do you think that will work in the present? I don't think so. So the future competency will be different. And second, we have to do target scoping. We have to do the scoping appropriate for the reality. And even so, I think there will be discrepancy between reality and the idea. So we have to have the clear understanding about the restrictions. And fourth, from the business perspective, we have to think about how to connect the dots. Well, we have technologies, but what's important is how to connect the technologies with business requirements and the orders made by businesses, which is very important. And let me tell you some recommended scenarios regarding the connecting dots. And lastly, I'd like to talk about full potential. Well, if productivity goes up, cost will go down. That can be benefits we can achieve, but other than that, there can be other meaningful benefits. For example, we can talk about qualitative benefits. We are talking about ESG, and nowadays, well, without any hard physical work, maybe we can work more convenient way, but we can do some meaningful work, and that's the message that I want to come across in the last part of my presentation. So this is a diagram regarding logistics center. I think that you may not be familiar with logistics center, and I think there are some people from academia and research center, but there will be less people who visited logistics center directly because logistics center are located in a remote area, and in the center there are lots of automation facilities already deployed in the center, and an auto store and automated facilities have been adopted by some companies, MBP, DPS, DAS, and automatic sorter. The terminologies may not be familiar, but anyway, these automation facilities have been adopted widely. But even so, in the logistics center, it requires lots of manpower, like 100 people, 200 people. In case of large logistics center, they have more labor forces inside the logistics center, and they work really hard, but there is inefficiency in the center. Why is that so? Because business environment has been changed. Well, B2B, business to business, is the past practices, but unlike the past practice, now we are moving to e-commerce, and we are using coupon and soup.com platforms, and if we order online, we can get the delivery. But lots of labor activities are needed to deliver products. So even though we order only one item, we can get it delivered. So we have to think about frequency. For example, on the weekends, if there is a special discount program, lots of orders are placed, and logistics center have to deal with this order. So even though there has been technology development, productivity went down in the logistics center, and the utilization of the facility or capacity utilization went down in the center. And in Yongin and other remote areas, it's very difficult to hire or secure labor force because labor costs went up. So the only solution to solve this problem is autonomous operation or unmanned operation. Business environment has been changed already, but we have to think about whether technology is catching up with this changing business environment. So in our company, we have technologies that enable autonomous driving or operation. For example, forklift can do the internal scanning to understand the location. And there is a technology to reduce the gap between autonomous driving and the real condition. So through this, we can do the sensing. So the machine can work as the arms and hands and eyes of human body. So machines can operate autonomously. And GPS is one of the enablers. In the past, it was difficult to deal with lots of data, but now it's possible for data handling. So in a 2D, 3D, it's possible to sense whether there are objects or humans nearby. And Tesla has that technology as well. And so line sensing or border sensing is possible by this technology. And if there is unmanned forklift, this unmanned forklift has to work with humans within the center. If you watch the SF movie, it's like a 100% unmanned factory. But to achieve that vision, I think it will take more than 10 years. even though we hurry up now, it will take some time to achieve the vision. But until then, we have to think about safe operation and safe harmonization between human operators and unmanned the machines. So during operation, we have to think about the blind spots. We can address this problem using LiDAR technology and ultrasound technology and 3D and cameras by converging these technologies. So of course, it will not be complete or perfect, but through this converged technology, we can reduce harm to human operators. So Mobius, our company, we are dealing with unmanned forklifts and related transportation technologies, and we sell these technology to our companies. And if you look at our standard products, so this is manned forklifts, and if you can see here, there are 13 different sensors inside. We are using Waymo's LiDAR, and we convert lots of sensors in a dense manner to enable very precise operation. So what will be like for the future logistics center? We can, of course, enhance logistics center. For example, we can do the multi-stacking in the block environment, and we have a rack in the logistics center. We have 4 legs or 5 or 8 racks. So we can achieve this multi-stacking and multi-rack environment, picking and packing, and we can enable horizontal movements like a vehicle. But to enable this, we need to have a robot. But at the same time, the robot should be connected with a system like an order management system. If you place an order on the Coupang platform, there is the order management system in the back end. So we have to connect the IT system with the order management system. I think that is very important, and there should be a very close connection between these two elements. Otherwise, even though we have good elementary technology and deep learning, in reality, if it is not related with business system, and if we do not understand business system, we cannot achieve utopia at all. So we have to be more realistic to connect these dots. So in the past, if you look at the left-hand side, these are characteristics of past logistics. There was optimization and innovation in the B2B environment. However, world has changed and we have new technologies. So we have to have new elementary technologies, and deep learning and big data, algorithm optimization, and traffic management are also important. But on top of that, business application compatibility is needed, and there should be linkage and connection in a millisecond, in a real-time basis, and there should be dynamic analysis as well. And on the right-hand side, that's the competency required in the future logistics center, and that's what we do in our company to help other companies. So I can summarize in 3 factors: planning, management, and robot management, and logistics and manufacturing management. And there is a robot, but before then there should be data synchronization, and that's something that we shouldn't miss. That is, if we are the company that produce unmanned forklift, you may not know related systems or components. So who should be responsible for the connection? Without connection or synchronization, we cannot achieve optimization. On the one side, there can be optimization, but on the other hand, there can be bottleneck. So we have to make sure that there is a connection between these 2 different elements. So on the upper side, we have to formulate a plan to connect things. And we are thinking about robot technology and 5G and system capability, engineering and design capability. And we need to have these things in a holistic manner. Only then we can make things feasible. So we don't have to talk about utopia or the cloud. So we can enhance feasibility or this kind of reality. So when you buy a thing, in the back end there is a factory and a warehouse and storage for finished goods and district logistics center and deployment center, and they deliver product to us. So there is this kind of flow of logistics. So there can be 18 elements of flow. Can we adopt robot for all these elements? Well, we have to think about that. And we can apply the robot to the simple tasks first. Or we have to think about our readiness of infrastructure. So let me go deep dive for analysis. Well, there can be common denominator among the industries, and there can be differences. We call it variant. So for characteristics, depending on the characteristics of industry, we may not cover everything with robots, but if we go into detail, there is a gray box and a blue box and the navy. The gray box means that that's something that we can cover. So depending on the opinions we heard from our customers. So there are 18 elements, so it's already possible to apply robotic technologies to these elements, but we do not apply in reality. That's something that we have to think about. So if you look at these cases, well, we are talking about smart factory and factory automation, and we are talking about these initiatives. We have automated factory and smart factory on one hand, and on the other hand, there is opposite factory with lots of manual work. There can be 6 categories. So among these 6 categories, where do we have to apply the robotic technologies so we can do the scale up based on the lessons learned? Well, for the scalability, well, that's our priority. For semi-automated environment, if we adopt robotic technologies, well, we can enhance efficiency or reduce the cost. We can achieve the payback. So we determine that there can be some benefits. And for logistics environment, we can apply robotic technology to this area. So, but even so, in reality, there are limitations. So we are not from academia, so we are not working at the laboratory, we are working at the field, so there are limitations. Well, we have a limitation of physical infrastructure. For example, regarding location of products, we have to think about whether we can manage the spacing or location with the data. And with the data operations, is there any link or connection with a human operator? So there can be hard constraints and soft constraints. And as for the hard constraints, I think that it will take more time. However, for soft constraints, so we can innovate processes, or if we change the way of working, then that's something that we can overcome easily compared with hard constraints. So if you look at the cases, in case of outdoor environment, not indoor environment, sorry, in case of indoor situation, we can apply a forklift. However, as for the external situations, it can be affected by illumination and and other elements like rain and so on. Tesla, there was a news that Tesla had an accident with the white objects because it couldn't distinguish the median separation line. So there can be some like some error, margin of error in case of vision recognition. Because of that, we can start from the indoor environment or the facility with rooftops rather than external situation. And for the location, there can be separation, but at the same time, there should be systematic synchronization using XYZ coordinates. We have to make sure that the system can give the signal, so that's fully feasible. So there are checklists like facility technology can be assessed using these checklists, and I recommend you to have the consultation with professional company. And this is the fourth part of my presentation. This is our service scenario considering E2E operation. So we need to come up with very concise service scenario. I start my presentation 10 minutes behind the schedule, so I think I have time until 2:10, so I have 50 minutes left. So there are 12 standardized service scenario. Like first, this is goods receipt. That means you put a good inside the warehouse, so you store inside, and if there's an order, you release the product. So there are 12 different scenarios to make the process more efficient. This is kind of asset for a company. So what to do with the operation? So I'm talking about unmanned forklift and how unmanned forklift can work with a human operator. And the red box, you can see the red box in the slide. This is about fulfillment operation related with e-commerce. So let me explain using diagram. On the left hand side, the car is coming and the goods are coming into the logistics center and it is moving to the storage. So there's a flow from the left to the right. So I think that you can understand this intuitively. So you unload the product from a truck and you use the unmanned forklift to transport, and the forklift is putting products onto the rack. This is about center's layout. So which space the job is done, and the roles and responsibilities of unmanned forklift and human operator, and how to synchronize with data. And I think this diagram can give you a tip or solution to address these problems. Of course, there is no one size fits all. Well, your situation may be different from other company's situation, but maybe you can understand this as a reference or standard, so you can use this as a starting point and you can modify this scenario. And this is a center, and you move goods, and this is cross-docking. Through matching, you can transfer goods. And we also have full pallets. Full pallet means that rack has 100% of goods. So pallet is bigger than the box. Well, one pallet has around 50 to 60 boxes. One pallet has 50 to 60 boxes. If you've been to Costco, in the Costco there is a pallet. So this pallet is equivalent to that the pallet in the Costco, so you can transport goods, and the jobs afterwards can be done by human operators. And pallet picking, well, on the fourth and fifth, on the 4 or 5 rack, there is a storage rack. Do you know the height of rack? The rack can be 18 meters. The human operator if they use forklift to unload the pallets or products, well, it will be very risky and dangerous. There is a possibility of dropping products in the process of unloading, and there can be domino effect as well. And you may saw the articles in the newspapers, so they can lead to industrial accidents. If a human operator tries to unload product from a high place, there can be an accident. There is a tower crane in the apartment, and there should be some professional operators for that operation. The same goes for the center. And we have to utilize the camera sensing rather than using the intuition of human operator. And this is person to good. So person to good can be supported by the system. Let me skip this part. Humans and robots can be connected each other. So we call it collaboration robots. So it's kind of pairing between humans and robots. So I can pull the robots, but unlike the methodology, there can be different matching and pairing. That kind of technology can be possible. So I'm not the owner of a certain robot. Rather, a robot is finding a human for a certain task so that the robot can get the help from human. And in the booth, there is a grouper robot, gripper technology. Well, gripper technology has not been completed. Well, Amazon has a gripper challenge, but maturity level is not that high yet. But still, we need some human operators. So we propose the guideline for this operation. It's absolutely possible to move products using robot, and allocation can be done by robot, and inventory moving can be done. So maybe robot can move inventory from this place, that place, that can be done by robot, and system can manage the process. Imagine that this place is full of products. You can use the scan app using a smartphone. If you walk around the large center for stock taking to check or inspect how many products are left, do you think can you do that? Well, it's too much. And human operators shouldn't do that. That should be done by robots. And human operators should focus on analysis, more sophisticated operation. And if you attach the vision camera into robots, while robots are moving around center, the robot can do the stock taking and check the inventory. And robots' value chain can be composed of these four elements: PDA and tablets, picking cards. The auxiliary devices can be utilized to help with the logistics operations. You may have some questions regarding the capabilities of robots. In that case, please contact me, then we can have some meeting and we can provide you with consulting services. So we can provide you with operation model depending on scenario. So you can facilitate your process of adopting the robotic technology. So on the right hand side, there is a benefit. For example, you can reduce the labor costs and overwork. Second, you can reduce the overwork. For example, if you had to work 8 hours or 9 hours, and your standard working hours is 7 to 8 hours, but if you have to do work overtime, like by 2 hours, it can lead to labor cost increase. But there are many cases where overtime work is not necessary if you work efficiently during working hours. Like during working hours, if you work really efficiently, you don't have to work overtime. And there are many different methodology to deal with the peak season. Well, during the normal situation, ordinary situation, we can deal with the situation. But so, for example, like out of 12 months of a year, 10 months may be normal season, but about 2 months, like a Lunar New Year and or Thanksgiving Day, so they can be peak seasons or seasons with event promotions. So with the system, you can respond to these peak seasons. And when there are new employees into the center, the system can help with the employees. So you can. So it will take a lot of time for new employees to adapt to the new environments. So in case of onboarding of new employees, we can reduce the lead time for the new employees. And the picking productivity can be more than doubled, even though you calculate it conservatively. For example, in case of picking of 80 boxes, you can collaborate with robots. You can avoid unnecessary operation, so productivity can be doubled, more than doubled. So to make a decision making for adoption, of course we have to assess the benefits quantitatively. For example, if you have the distribution center, and if you have the regional center or district center, and if you are online company and if you have a fulfillment center, there are commonalities. They have the same priorities. They are thinking about reducing labor costs and increasing productivity, and you can make a decision by very simple calculation. So how to change the mix of workforce, and how about the capex when you adopt the facility, and you also have to think about depreciations and the depreciation cost and IT operation costs and the power, electricity. The power bill goes up because this is unmanned forklift, and then you have to calculate maintenance costs. So you can compare the total benefits with the total costs. So the net benefit is around 2.4 times higher, and there is a payback period. And after you make an investment, like a capex investment, how fast can you get back the benefits? This is payback of ROI, so you can get the payback within 3 months. So in the worst case scenario, you can have the payback, you can achieve payback in 1.5 years. And we have these methodologies, and on the left there is a baseline, and we conduct the A/B tests. So we think about cost factor, productivity factor, like the number of processing by minutes, and the walk count, and the material costs. We calculate all the costs factors, so we can quantify the benefits of the system adoption. So you can get this kind of quantitative benefits. So I told you earlier that you can calculate the benefits by very simple calculation, but that's not the end of the story. We have digital twins technology. We do the simulation modeling using digital twins for calculation. People are talking metaverse these days. So basically, we have a simulation modeling tool. So through this, you can understand where is operation space and where a forklift is lifted and where should be collaboration between humans and machines. And for this end, we can conduct the A/B testing. If we change this thing, for example, if we automate these facilities, how that affect the result. So we can do the kind of quantification. You don't have to eliminate the rack and add a new one. In the virtual world, you can do the simulation for analysis. I think that virtual analysis is a blessing of this IT development. So with less cost investment, you can do the analysis. And according to the recent study, we did a modeling analysis for 30,000 square meters of center. For example, we can calculate how many forklifts and how many people should be input, and we can calculate cost, whether operation is feasible. We can cover all these things using modeling. And we can also achieve qualitative benefits. I am involved with unmanned forklift, but I'm really hesitant, or I have reluctance to job loss. Well, if there are 100 people, they can achieve 10 billion Korean won. But without increasing manpower, they can achieve the profit by 20% or 30% higher. And when it's very difficult to secure workers, you can utilize the system to increase productivity. And night shift, 2 shift, 3 shift, night shift, that's something that people are reluctant to, and they are prone to industrial accidents. So the logistic robot can address these problems. And please contact us, and we can share with you our modeling technology and service operation, and we can talk about quantitative and qualitative benefits. Thank you very much.
네, 강연 잘 들었습니다.
Thank you for the presentation. Now we're going to invite Mr. Kim Kyung-soo of Auto Store. So, Mr. Kim, as soon as you're ready, we'll begin with your presentation. I think I may begin. My name is Kim Kyung-soo of Auto Store. Excuse me. You are seeing an English presentation here, but I think I have a Korean presentation as well. So let me begin my presentation. You may have heard about Auto Store. There is it's a Norwegian company that makes what's called the cube storage robot. And why are we talking about e-commerce? Well, there are many reasons as to why we could talk about e-commerce, and that is why I'm here today to talk about the e-commerce. I'm going to talk about our company and our system, and then I'm going to show you briefly our references. And the ASRS, which are needed in the e-commerce. Now, how are they made possible with our AutoStore? So that is what I'm going to try to show you. Why AutoStore is growing so quickly and is playing an important role in the e-commerce industry. That's what I would like to talk to you about. Well, AutoStore has developed a new storage method called cube storage. Well, this is a completely new way of storing products, like in Lumitube. So each tote is not going to be put on a rack. They will be the totes. So totes will go on top of the totes. So that's what this system is about, and that's what we call. And that is what's called the cube storage. And the robots are needed here. People do not do the storage work here. And as to the background, up until the 1990s, well, AutoStore was a company that was distributing electric components, and the company did very well, and it was increasing number of warehouses, and even they increased the number of warehouses physically. Well, they had limits in dealing with the inventory and dealing with the flow of materials, and so they came up with AutoStore, a cube storage method to deal with this excessive inventory. And this is the only company that is selling a SRS product with cube storage in the world. Well, sometimes in a warehouse there are more empty space than the actual products. So between the shelves, there are the corridors, and then from a company's point of view, it's all money, those empty spaces. And many companies have had this experiencing of not having enough space in their warehouses. And with the AutoStore, hundreds and thousands of the electronic components could be stored. And then there's this one big problem, that is operators. They have to look for a product in this large warehouse. Well, there are many companies in Korea, large warehouses, and the operators, they have to walk in tens or a lot of kilometers to be able to pick the products, and that's physically daunting for the people, but that's also at the same time very inefficient. If this could be automated so that the product could come to the people, then it would make work a lot easier for the people, as well make business more efficient. And to in the process of picking and in the process of shipping, well, there are very complicated processes, and in order to deal with those complicated processes, there are a lot of efforts that go in, as well as manual work. And the company wanted to come up with a solution to deal with all these problems, and that is why the company started to developing a system that now ultimately becomes an AutoStore. And AutoStore has a patent that it has received for the first time in 2005. The first product delivery was made, or the first installation delivery was made, and in the beginning it was began with a small robot. And the first installation is doing quite well. The size has not expanded, but it's doing quite, still in operation and doing quite well. And globally, according to the data I have about 2 weeks ago, about 780 different sites with about 50,000 robots. There is the operation. So in less than 15 years, the company was able to grow very quickly. I don't know if any of you have heard about this, but about a week ago, and our company was listed in the Norwegian stock market. And in April of this year, SoftBank actually acquired 40% of our company's share. So it is actually a unicorn. And lately, when you may say that the companies that may make hardware could not become a unicorn, but we could actually we can prove that even in a hardware maker like us could become a unicorn, and I'll talk about this later on. And this shows the auto store sites. The countries with that are shaded red have the largest number of installations, followed by black and then gray. Countries such as Norway, Germany, the U.S. and Japan have the largest number of the installation of the auto store. And in case of Germany alone, there are over 300 sites. So there are very small installation as well as a large installation. In case of the United States, the installation sizes are quite large, and in case of Japan, well, it's mostly the small-sized installations that are in operation. And we do have a reference in Korea. However, there are actually 4 completed sites. By next year, we'll have about 7 installed sites. And we have installations in France, Italy, and UK, and the number of sites are increasing in those countries. And auto stores doing so well because of the industry that is available as of now. In past, in the traditional manufacturing and the clothing companies, or they have a very complicated logistics, and with the development of e-commerce, and on top of that, with the pandemic, these companies grew dramatically. And then in 2021 compared to 2017, 2018, we are expected to grow about 150%. And by sector, these are the sectors where the auto store is doing well. And if you would look at the bottom, you see healthcare, automotive, mechanical parts, building and construction, electronic components, and the tools, aviation are some of the sectors which are the traditional sectors. And then in the past 4 or 5 years, where there is an increase in commerce in the sectors are the 3PLs, the apparels, groceries, and the sports apparels, electronic components, home supplies, and the luxury and the beauty products, and the general retailers, office suppliers, toys and games and books and media are the sectors that are increasing rapidly in terms of e-commerce business in recent years. And these are probably the industries with the sectors from which you are also buying your products online. And there is a significant growth in the so-called 3PL. And in this age of e-commerce, the fulfillment service is very important. Well, the B2B logistics of the past is now more of the B2C. We see more of the B2C logistics. As a company that used to be in the 3PL business have moved to the e-commerce fulfillment business. And the new startups, they're getting involved in the fulfillment business. And that is, so these are the reasons, and these are the trends that are contributing to, to excellent business results of auto store. And in the e-commerce, there needs to be a lot of accuracy or precision in terms of the operation, and that is why auto store has become so popular among our clients. And these are our clients. I used to see many famous companies here, and then we have far more clients. Clients that are not on the slide. There are really small companies that do not really have the logos or the websites. Well, these are small. There are a lot of small German companies that have actually bought our products. And so, because those companies need automation, and those companies in particular need automation in their logistics work. And when it comes to distribution and the logistics in the past 2 years has been growing so quickly because of the pandemic. And however, when it comes to storage, all the work had to be done manually. That is in most companies anyway. And so we believe that in terms of storage, there's going to be a lot of automation taking place as well. And the office here in Korea. Well, we have plants in Poland. We have a head office in Norway, in the UK, England, state, France, or well, we do have offices, Spain as well. So, so we Korea was the sixth country for the company to open up the branches. That is because Korea has such advanced logistics. And in terms of e-commerce, Korea has the highest level of e-commerce business. And so in terms of the size of pure size of the e-commerce market, Korea is about the sixth largest. And Korea also has the quickest delivery system. And so there is a great potential for automation. And auto store, we do not sell directly to customers. I'm sure we have people from many different businesses attending here. We sell our product through our distributors, our partners, that is. And our partners do marketing as well as designing and actual installation and after-sales services. We, here in Korea, we are working with companies such as LG CNS and Samsung SDS and Asetec. And you may be very interested about the system that we have. And auto store it's a very unique system. Compared to the shelf warehouse, well, we have about 3 to 5 times more storage density because of the cube storage method that we use. We don't need alleyways, so we need the corridor, so we do not need additional space above the shelves, and so that we could use the space to the full. And this storage density and can be utilized to do more business. So what do I mean by this? Well, let's say that I have a warehouse now. And in about a quarter of that space, I'm going to put everything in there. And the 3/4 of the other spaces, I'm going to do something else. So that, giving opportunities, to do other businesses. So with the same kind of money, I would be able to buy a land that is about 1/4 of the space that I would have had without the auto storage, and by doing so, I'll be able to become closer to the customers. So instead of having the warehouses far from the city, I will be able to have the storage facility nearby the city, thereby become closer to customers. And a lot of people talk about NFC, which I don't think is going to be an easy way to achieve. But NFC can be used in here. And so in a city, in a very small space, if I can pack in as many goods as much possible and then do the fulfillment. Well, you can do that with the auto store technology. And with the auto store, as you can see from the right hand side, the products do not have to be the space does not have to be a square. There could be columns, and it can be installed in a tunnel way. It can be set up through a bridge. So it's very flexible in terms of stacking things. And auto stores could be set up on stairways as well. And the existing oil stations or the gas stations could be made into stores. And so you could use any space, to make it into your fulfillment center. So that's an advantage. So how would this system work? And the bins here are the bases. And these bins do not go on shelves. And the bin on top of bins will be stacked. So the totes, just like the totes you see on the yards. So the bins will be stacking on top of each other, and then the robot will be moving around and taking down the bins one by one from the top. And you may think that this is too slow, and you may think that the robots would have to move very quickly. And AutoStore has advantage in that. And the robots will be able to move anywhere. So all the robots can pick up all the bins. So stepper cranes or the mini roads. Well, and these these devices or the equipment was responsible for a given zone, but that's not the case for the robot. The robot could go anywhere, and the robots could collaborate with each other, and that is because in AutoStore it is possible, to simply pick up the bins at the top. And in case of grids, well, grids are tracks on which the robots could move, and ports is where the picking and put away are performed, and there is the controller, which controls the overall logic. It's a controlling system, and in fact. And if you would search AutoStore on YouTube, you could find a lot of videos, and you may have seen the red robots. And the red robots are called red line. It's called red line. And on the right hand side, you're looking at the black robots. In the videos, you may not find it quite easily, but it's it's a step up from R5, from B1, R5, which is red line. And out of 25,000 units that we have sold, about 23,000 or so are R5s, because they're relatively cheap, and it may not be cutting edge, but it's relatively cheaper, and the maintenance is easy, and the usage is quite easy, and it weighs about 140 kilograms, and it's heavy because of the lead battery. And the maximum load is about 30 kilograms. If anything that goes beyond 30 kilograms would not be able to be stacked into R5. And the maximum speed is about 3.1 meters per second. And the acceleration, as you see here. And so we would account, this one would account for 2 cells. And the AutoStore, you can go anywhere that's open, and the more way to move around the system will become quicker. What does that mean? If the robots themselves have a smaller footprint, that it would be better. That is why we came up with this robot called the B1. And the B1's footprint is only half the footprint of R5, and R5 would hold the bins from on the outside. But in case of B1, the bins are inside the B1. And that is why it has much smaller footprint. And it uses lithium-ion battery, which is would make it much lighter. And the speed is about 4 meters per second. And so that is a 30% improvement. Acceleration is about 1.4 meters per square second. And the speed is important because with R5, which we sold which is the product that we have sold mostly, about 10,000 or 20,000 bins, or were considered to be a larger system at the time, but the size just getting to be bigger, like 100,000, 20, 100,000, 500,000 or so. And so, which means that they would need a lot of system, and the robot would have to move from end to end, and they would have to move very quickly, which means the acceleration has to be fast, and the driving speed has to be fast as well. These two robots robot, the temperature is room temperature, which is between 2 and 35 degrees. And so AutoStore could do refrigeration, but not freezing. Now, you're looking at robots because but what's really important are the bins. And the bins can carry about 30 kilograms at most. And there are different heights of bins that depending on the height up to 14 from 14 to 22 bins can be stacked onto the robots. So the bins themselves have to be able to uphold quite a bit of load, and the bin at the bottom will have to be able to uphold about 800 kilograms of the load, which means that the bins have to be very, very sturdy. And so here you see these 3 different bins that we have, and you could use these bins separately, and you could use the bins without the partitions that you see here. And the sizes, the dimensions are as you see, 60 by 40 millimeters. And so, you may wonder, how can we do such a good business with such, small baskets? Well, anyway, you're looking at the grade of AutoStore. And so all fully installed system is called grid. And so there will be covers, so you will not be able to see what's inside. Because of this video, we have opened the covers to be able to show what's inside. And I said R5 is simple because it has a belt structure. And the DC motor and the belt operated, so mechanically this is very simple. So even if something is broken, it's quite easy to fix. And because it's easy to fix, we have very, very short downtime. And here, so the robots are taking out the bins. And in the crane, well, you see the cranes going down, and with the hook, it's carrying the bins. And here I'm moving really quickly. And so the robots are moving quite freely. And this is what's happening within our grid. And here you're seeing the ports where the operator picks out the product or takes out the products. And the operator will take out the product, and the robot will take that away. And so the bins will be delivered to the operator continuously. As I said that the things are picked from the top bin downwards. And if we have to take out the product at the very bottom, and there are 16 bins stacked together. You may wonder that and you may think that it's going to take a lot of time. And if AutoStore has to take out the lowest toe, what should I do? So it has to take out all the totes at the top, and it would have to be placed around the cells. And then while the robot is taking that tote to the operators, other robots would come here, will be restacking the bins. And so the products that the operators call out often will be going up at the top of the bins, and which means that the robot will not have to go down to the lower bins. So the law of the parrots would apply here. And so most of the customers, they would mostly use, but 90% of the 90% of the products or the things that they take out will be on stored at the top or the right below the top bins. And additionally, what's done is this.
오토스토어 시스템 자체에 작업자가 작업을 시작하기 전에 한 30분, 뭐 20분 그 정도 먼저
And
이제 WMS에서
the
오토스토어
WMS will show the orders to the auto store, and the robots will take out all those products and get them ready. And the products at bottom will be brought up to the top and or brought too closer to the operators. And when the operator is just starts the operation by pushing the button, and the product will just the things will come to the operators. And as the operators are doing this sort of work, and the robots are preparing the next time next products to be delivered. So the robots are not will not be idling around, and designing that sort of workflow is the core work.
제가 말씀드렸던 그 EQ 위주 적층이
And so this is how it's done here, the slotting. And
실제로 대부분의 피킹은
most of the picking, as I said, is done at the top. So it does not take much time to pick up the product or the goods and bring them to the operators. And the preparations are done in advance, so that would make this very quick. But there will be some orders, like urgent orders, and so if you're going to take out the things from the very bottom bin, it takes about 3 minutes or so. And so even if from to take out the product, the good from the bottom bin and to deliver it to the operator, it would take about 5 minutes. So that it's not a long time. And then there's this conveyor port, and then there's a carousel port, as you see here, and then there's also a relay port. So there, and in case of the conveyor port, this has been with us from the very beginning, and per hour, this port is able to process about 180 times picking. And so in front of the operators, the bins can be delivered 180 times. And so that's about 180 times per hour. And so per operation, it takes about 20 seconds. And then there's called a carousel port. This is faster. It's about twice as fast, in fact. And per hour, the average speed, about 350 times of picking is possible, and that means that the work operation time is about 10 to 15 seconds. And so, if it's going to be below 20 seconds, then you can use the carousel. But if I'm quicker than 10 seconds, I want even more speed, and then you could use the relay port. In case of the relay port, every 2 to 3 seconds, the picking could occur. And so this speed difference, that means per part, how many robots could be aligned. So in case of a carousel, there are 2 robots attached, or that is assigned. And in case of relay ports, 3 to up to 6 robots can simultaneously be connected or could be linked. There's a mini road or shuttle, which are our competing systems. And for us to have the quickest, we wanted to make sure that we have the speed, and that's why we came with this port to be able to have a quicker shuttle time. And so we want. And about controllers. Well, I don't think I need to talk about this much, but let me just say this. AutoStore, it does not do inventory management, or it does not manage the shelf life management. AutoStore simply
안에 들어있는 각 기인의 아이디를 정확하게
uh,
파악을 하고
identifies the IDs of the bins and track the IDs accurately and pick that ID as quickly as possible and can order the picking of the goods in those bins as quickly as possible. And which ID bin to pick is decided by WMS. And so AutoStore only does what WMS instructs it to do. And so as long as there's a smart WMS, it will be possible to maximize the capability of AutoStore. If you don't have such a system, and if you're going to work line by line, then you could use the functionalities available within AutoStore. And one more thing about the controller, and there are functions that are user friendly. In the AutoStore, that is for the 15, 16 years, well, all the AutoStore system that have been sold, we are measuring average utilization per week, and the utilization on average is about 99%, 99.6%. And other compared to other ASRS, it is about 10 to 20% improvement. And it is able to do so because mechanically AutoStore is very simple. There are many robots and many ports, and so there's a lot of duplication done here, redundancy, excuse me. And so if anything doesn't work, then it does not work properly, and the operator just has to just bring that robot out and resume the work, and then the robot will be able to replace that work. So there's very little downtime. So the only downtime is just to bring up the robot that is not working. And with the second line, with the shuttles, I mean they are heavy equipment. They're high, that is the height is tall, and the machines themselves are very heavy because they are all made of steel. And mechanically, they're very complicated and have a lot of components. And so the users are not able to use those systems, and they need special engineers to do the maintenance work and the goods in that particular eye that where the system is broken will not be able to take it out. But that's not the case with the AutoStore. And the user interface is excellent. And because these are machines, they will break down from time to time. And however, the fix-up can be done immediately. So AutoStore looks like this. You've seen various types of grids. All the AutoStores are very different shapes and forms. There are tunnels, many different shapes, and the locations of the port can be changed. And this is, you're looking at the bins being stacked at the top. You see at the grids, you see the robots moving on the tracks. And these are the columns. And on the right hand side, you see a service area. And this is where the users and the engineers will go access the grid from here. And here you see a carousel port and conveyor port. Because of the speed difference, a lot of people use the conveyor belts for the goods, incoming goods, and the conveyor belt they're using on the outgoing shipments. And AutoStore is good in that these large systems, that the companies have bought, sometimes are not able to use them properly. And because our systems are different from the existing shelf systems, so we have our own designing tool with just a click and drag way. But the grids could be created, and the stack numbers as well as the size can be decided, can be adjusted. And what you're looking at is not something that I made myself, and that is something that is out of our grid design functionality. So you can look at the in 3D way what the grid looks like, and you could do the simulation as well. And this is our simulator with our tool. But customers have, different custom order requirements, and it's not possible. I mean, within the grid design, we could incorporate all the requirements, and based on the actual order data with that profile, we can do this actual simulation. And you may not be able to see here with the simulator. We will be able to see how the robots are actually moving around. And with the results of the simulation can be shown in graphics. And with that simulation results, it would be possible, to come up with the robots needed. And so once the design is done like this, because design is like this, there is a very high investment efficiency. And so many customers, because the auto store could be small, so they first choose smaller sizes, and then so they do the experiments, and then they see this works for them, and then they would move up to larger sizes. And so this way, companies are expanding the system per year, and I have the references here. And in terms of sizes, the smallest system in the world has about 350 bins. And this is actually a case in Bosch Rex in China. And the largest system has about 750,000 bins. And that's the largest auto store system. And so there are many different heights, different sizes. And I talked about the NFC. And the NFC model that's doing well in the US looks like this. So in gyms, you don't just exercise. You sometimes buy, sporting items. So which means that so you could buy, sporting products online and simply pick them up in gyms. In electronic stores, the customers could place orders online and pick up the products, somewhere around their homes. And the red ones are the auto store. And there are customers that have applied this concept into to their business. And besides this system, what I talk most about to the businesses is this. In the past, people had to move away from the city center because of the cost. So in times like this, instead of buying expensive land to set up the warehouses, now they can use our product to be able to efficiently and quickly store their goods or products in much smaller land space that is closer to their customers. And this way they can increase delivery speed and reduce the operation cost.
이제 실제 그리드를 몇 가지를
And these are our references. And this is the smallest, with about 350 bins. And so if a person looks like this, the height is about 4.5 meters. The system is very low, and this is auto store in a mall in Thailand. Within a mall, you may see an auto store actually moving around. And this is SK Pharma, a company in Germany, and H Mart in Korea. And the H Mart is actually doing business in the US. And this is company in Saudi Arabia. This is a chilled grid. And the auto store is within the chillers. But in the future, auto store grid will have chilling capabilities going forward. And this is for Lotte On. This was introduced in 2019 in Busan. And for the first time in the grocery industry, Lotte Super was able to apply this concept of NFS. And when this was first planned, Lotte was going to have 10 sites nationally. But and the locations are not that far from the city centers. And for e-commerce, where the project is on hold, but in Uang and Busan, there are 2 sites in operation. And this is a company in Kuwait. And this is a grid of a German company for dental offices. And here you see everything stacked together very closely. And this is something that Siemens is using in plants. So for the materials, raw materials. And this is for Boston Scientific, which is a medical device company. And it shows many different the forms of auto store. And the ports, or the mezzanines. And so this will represent the strength of auto store. People from the US. And the relay ports are used here. And here you see the tunnels. And these tunnels, when operators do the picking, and then they have to go to the packaging line. and the conveyor lines can be set up here. So sometimes they are installed on the ports. Sometimes separate tunnels are created like this, and some are using these tunnels for evacuation corridors. And this is a site in Italy for a semiconductor company, and this is HelloFresh in the US. And see the port looking like this. So the robot will move around like this, and there will be a corridor in the back. And here there will be conveyor ports for the incoming goods. And there's a company called Adore Me in the US. This is and in this company wanted to be close to New York, but they were not able to buy the land because the land was so expensive. So they got a space in New Jersey where they built the warehouse. And this is Medline, a medical supplies company. And Medline already has deployed about 18 sites with the auto store. This is Texas Instruments, electronics components company, and they have a grid that looks like this in Singapore. And a company called Steel that has mechanical tools, and Puma. Is significant for us because this is a traditional brand, and it's winning in competition against e-commerce leaders like Amazon because of its very unique e-commerce strategy. And it's a company that focused on the delivery speed. And people, they are willing to pay the delivery fees. They don't care how much the delivery fees are as long as they are able to get the products they want as quickly as Friday. In that case, Black Friday, if you place an order, you will get your product in about 10 days. But Puma, they were able to streamline their distribution channels and improve an automation. And they, of course, you are using AutoStore, and they have been able to, of course, improve business. And even on Black Friday, Puma is able to deliver the product 2 days after the orders. So even the traditional company, they will be able to have the right e-commerce strategy and thereby have a competitiveness. And besides Puma, companies such as Biggs or the Best Buys, these traditional companies are transforming their e-commerce strategies in order to survive. And of course, they have all introduced or have installed AutoStore. And this is a TTI. They have a very large AutoStore grid. And this is XXL. It's a Nordic company. It's an e-commerce company that sells clothing. In 2011, they first bought or installed AutoStore. Every year, they have increased the number of bins or increased the number of ports or robots. And so they had one single grid. They were expanding, adding the robots or the bins. And this is a company that has the largest grid. And they have over 75,000. They used to have 75,000 bins, but they are going to increase the number of bins to over 900,000. And I'm not saying that we have to do like this in Korea, but I'm saying that it's possible to come up with many flexible strategies. Any questions? With that, I would like to conclude my presentation. If you have questions, please contact me. Thank you.
네, 강연 감사합니다.
Thank you for the presentation. We'll move on to the next presentation that will be done by Lee Seung-yong from Bangdae. If you are ready, please start your presentation.
네,
So let me start. Hello. We are involved with smart farm automation, and we are developing agriculture automation robot family. And my name is Lee Seung-yong from Bangdae. Well, when it comes to agriculture, it is being transitioned into smart farm. So how it is being transformed? About that, global investor Jim Rogers said that next generation opportunity can be found in agriculture. So how it is being changed and what are we like? So why did Jim Rogers said that next generation opportunity can be found in agriculture, and we can think about where we stand in agriculture? Well, centering around Netherlands, there is a fast transformation into smart farm, and IoT can collect the harvest data, and AI analyze the data, and as a result, the yield amount has been increased dramatically. For example, for 1 hectare cultivation area, if it is configured efficiently, it can result in the yield that can come out of the 1.6 hectare of area. But even though it is a smart farm, it still requires lots of labors. In particular, harvesting requires lots of manual efforts and it's very demanding. And harvesting requires the most amount of manpower. Then how about our reality? So to predict the future of agriculture industry, we need to look at the composition of the ages of farmers. I don't need to talk about statistics. Well, I think it has been with us for a long time that the farmers are very long, and the youngsters do not look at their future in the farming. That means that agriculture is not sustainable for them. And we are talking about food sovereignty, but no other industry is using the word of sovereignty, but food industry is the only industry that is talking about food sovereignty. That means that food industry is being threatened at this moment. So to harvest more crops, more manpower is needed. That's very obvious. So how can we solve the shortage of labor forces in the agriculture? And to secure labor force, how do we have to respond? So this is the agriculture automation robot that our company is developing, and we are very confident this can be a solution. For simple repetitive work, the robot can do that job, and the robot can help with harvesting in a timely manner. While in the past, the horses and cows were replaced by tractors and other agricultural machines, likewise, smart machine can replace these kind of past farming machines. that's the direction that we are going at this moment. And as you can see here in this slide, when you think about automation, robot, that something that comes up into your mind is factory and smart factory. And so far, the farming has not been standardized or structured, so it was not being easy. Actually, it was very hard to apply the robot technology into farming. However, in Korea as well, smart farming is being developed and applied in a fast manner. That means that farming is becoming structured and standardized. And under this structure, automation solutions can be applied in a very easy manner. And if automation solution is applied, we can secure labor forces, and as a result, productivity can go up. And then how about the smart farm in Korea? Mostly they follow the Valono greenhouse. And the annual growth rate of smart farm in Korea is 6.7%. And Valono greenhouse is being expanded around the world. So it's kind of a standardized smart farm. And what are the strengths of Korea? That is IT environment. We are very strong in IT technology, so we can utilize IT and AI and robot technologies, and we can apply them comprehensively to robot technology, to farming environment. The penetration ratio of smart farm in Korea is low at this moment, but I believe in the future, Korea can become a leader when it comes to smart farming. And the agricultural automation robot is not far away from reality. And Netherlands at this moment has around 99% of automation robots. And in Netherlands, for farm of 1,000 hectares of farms, that big area is managed by 10 farmers. And the US ranks first when it comes to size in other areas, but when it comes to farming, the US ranks second after Netherlands. And the size of Netherlands is only 40% of that of Korea. So what are the secrets of development of smart farming in Netherlands? So what is the secret of having synergy effect in Netherlands, and how can we have a bright future in Korea? We can refer to Netherlands to find the answer. We can utilize computer vision and AI technology and apply them to robot automation. In particular, we can automate harvesting process of farming. That's what we do in our company, and through this, we can address the shortage of labor forces in farm. We utilize AI algorithm, and actually we develop AI algorithm, and based on this technology, we are applying this technology to paprika and tomato, the crops being harvested in greenhouse. And we have paid patent registration, and we are utilizing this technology. And for automation of harvesting, first of all, we have to recognize crops very accurately. That will be the starting point. And then the robot arm should approach the crops accurately. For this end, we wanted to understand the paprika environment and farming environment. We collected more than 20,000 image data for 6 months in farm, and we trained AI. And as a result, paprika recognition ratio achieved 90%, and the success rate of approach of robot recorded 99%. And based on this result, we developed prototype of agricultural automation robot, and we conducted testing in Yanggu province in Gangwon province. And at this moment, harvesting ratio at this moment is 10 kilograms per hour. Well, 10 kilograms per hour is around 50% of the harvesting ratio of experienced farmers. we want to increase the efficiency of robots, and we are having a collaboration with smart farms. And at this moment, but actually next month, we will reside in Sangju as a smart farm. So we will have our own smart farm. And Rendezvous want to make sure that robot can learn about agriculture and develop itself further. That's the solution that we are developing at this moment. And in 2022, we want to apply the automation robot into farms. That's our plan. So we want to expand this technology to farms in a fast manner. And for this end, we are collaborating with Pumashi, which is a job placement company for agricultural area. And robots and humans can work together to secure manpower for farms. And for that end, we will continue to come up with alternatives. And this is the landscape of facility horticultural industry. And the horticulture industry hires around 92,000 people, and harvesting is the process that requires the most number of workers, and it is suffering from the shortage of laborers. And what is important for farmers is to harvest at the right time and right moment. If they miss the harvest moment and right timing, and if they cannot harvest at that time, they have to destroy at the farm. That means that they do not harvest, and after the crops are grown, they are discarded. If they miss the harvesting time just by a few days, the crops lose marketability, and it will be impossible to put the product or crops into the market. And it was very regrettable. So we wanted to make sure to apply smart farming technology to the farms. So our first target is paprika and tomato. And we believe the labor force market for paprika and tomato is around 300 billion won. And by 2024, we will account for 10% of that labor force using our technology. 10% means 30 billion won. And we will expand our scope towards strawberry and potato. And we'll be able to accumulate lots of data, and in 2025, we will be able to develop robots that will be really active in smart farms around the world. And we are specialized in computer vision and computer engineering. And we are really interested in agriculture and computer, and we are like-minded people, and we share our vision together. Yes. At this moment, we are still thinking about how to develop agricultural sector further. We want to overcome the limitations of repetitive tasks where robots are moving just as pre-coded. We want to transform agricultural sector. And we want to open a new era of agriculture, and we will take the initiative of smart farming. Thank you very much.
네, 강연 잘 들었습니다. 다음 순서는 GTL의 이상호 대표님 준비.
Thank you, and we'll begin with the next presentation. Mr. Sang-ho Lee of GTL will be making the next presentation.
안녕하세요.
Good afternoon, ladies and gentlemen. My name is Sang-ho Lee of GTL, and today I'm not going to talk about a robot. I'm going to talk about a vehicle-mounted folding electric forklift truck that we have developed. And it's something that can be mounted on a heavy commercial vehicle that is more than 5 tons heavy, and it's portable, and so it's quite easy to load and unload this forklift onto trucks. And the motivation for the development of this vehicle is that the trucks are now able to load and unload the products. And they have to have the help of the forklifts to be able to load or unload the goods. And sometimes the forklifts have to wait. And sometimes the trucks have to wait if the forklifts are not there. And the trucks are losing a lot of time, and lost time is lost profitability, and that is something that's a pain point for the truck drivers. And if there are no forklifts available, they have to call them, and once they call the forklifts, it takes about an hour or so. And so this is a lost time as well as money for the forklift drivers, and that is why we came up with this forklift. And it has quite a bit of interesting functionality. And so the forklift can be attached to the back of the trucks. And in case of our forklift, we are foldable for the forklift. It can be folded as the name says. So it can be folded like this and loaded or mount or put into the bottom of the commercial vehicle with this large truck. And you don't need a license to be able to operate this forklift. And now we have wheels, and some are saying that this is a bit dangerous. So we are now going to have the forklift operated with a remote control. And so anybody would be able to operate this forklift with remote control beginning next year. And the forklift will be charged from trucks, and we don't need a separate chargers. Our forklift will be charged by the trucks. And so, the forklift, can be mounted onto the trucks, and once they're connected to the trucks, it will be charged. But the forklifts that you use in warehouses, they have large batteries that have to be charged. And in case our lifts are just for the trucks, and so we do not need large batteries. And this lift is about a ton in weight, so it has to be securely attached to or fixed to the truck. So we have a hydraulic safety structure with this forklift, so that the forklift will not fall off. I mean, should it fall off, it could cause quite a critical accident. And it's also quite a fuel efficient. and the fuel efficiency is almost as good as the normal or the ordinary forklifts that are already in operate, that are already used widely. And our forklift is only for a weight that is between a ton to a ton and a half. And there are a lot of heavy products, like beverages, that the heaviest is about a ton. And so the beverage cargoes can easily be loaded and unloaded with our forklifts. What you're looking at is a picture of our product displayed and at the Ministry of Defense. What we have, we have been chosen as a supplier to the Ministry of Defense, and this is for the factories. And you see how our forklift can be used in plants. And this is a forklift that is used in the army. And the army wanted a quiet forklift, and so we're going to have a lithium-ion battery on this forklift, and this forklift is going to be operated by a remote control. And this is a forklift that is going to be able to climb up and down the hills, and this, as I said, is going to be supplied to the military. And we are also trying to develop something for smaller trucks, about a ton. Usually the truck drivers for small trucks or these small trucks, or they're usually driven by people who have retired their old jobs and have chosen to drive small trucks, as a second job. And so we want to be able to provide our forklift so that the older people are able to load and unload the cargo easily from these small trucks that they are driving. And these forklift will be commercialized sometime in the second half of next year. And the loading and unloading time is significantly reduced because of our forklift. And I believe that our forklift is going to help truck drivers and the companies that are operating the trucks to have more efficiency. And so this is going, I've developed the product for the truck drivers, but I think that our forklift, because they do reduce the overall time of operation, and that is a reduced time of loading and unloading, it's going to be also beneficial to the owners of the cargo. And this, you're looking at a demonstration of our forklift. So that's a picture of that demonstration that we've had. And what you're looking at is a video of our product being demonstrated in the military. You're looking at the bin with oil being loaded and uploaded, and you're looking at how our forklift can be folded. And so in the future, with our forklift, will be able to reduce the waiting time for our truck drivers and thereby reduce cost, because in the future the drivers will become older and they will not be able to do they will not be able to do heavy lifting. And you know that there is aging population that's taking place in Korea, and our forklift will be able to help these older drivers to be able to do their jobs. And also help them to maintain a competitiveness. And this forklift, as I said, does not need a separate charging station. It can be charged by being connected to trucks. So I think our forklift is quite eco-friendly. And with this forklift in our company, in the future, we are going to provide the forklift for free to the truck drivers. With that, I would like to conclude my presentation. Thank you very much.
네, 강연 잘 들었습니다.
Thank you for presentation. We will move on to the next presentation that will be done by Professor Jung Sung-tae from Carolina University. May I start? Yes. So let me start. Good afternoon, ladies and gentlemen. I am Professor Jung Sung-tae from Carolina University in the US, and the topic today is measures to promote the introduction of industrial robots in manufacturing companies. And this is something that everyone in this room is very well aware of, and I just summarized my thoughts in this presentation slide. So this is background and purpose. And countries around the world are fostering and protecting manufacturing sector that creates stable and high quality jobs. And in order to enhance and maintain the country's global manufacturing competitiveness, various support and nurturing measures are being implemented. And as a part of this, robots are being actively introduced, especially in high-income countries. And in case of the US, a roadmap for US robotics is regularly drafted and promoted to encourage the introduction of robots in the domestic manufacturing industry. And in case of the EU, the Robotics 2020 multi-annual roadmap maintains the competitiveness of all industries, including manufacturing in the EU, through policy coordination among member countries and supports stable robot introduction support measures for many years. Then how about Korea? Korea has a very high proportion of imports and exports, so it is important to maintain external competitiveness. So maintaining global competitiveness in industry through the introduction of robots has become an essential choice. And the introduction of robots is no longer a phenomenon that only appeared in some advanced manufacturing processes in the past. Rather, it is being widely witnessed in diverse sectors. And in the past, the introduction of robots was limited to simply being introduced to various processes in the manufacturing industry. But recently, the fields of introduction and application of robots are expanding. However, with the introduction of robots, there is a growing social concern that the replacement of manpower by machines may result in a decrease in employment and deterioration in the quantity and quality of employment. In particular, Korea ranks very high in the world in terms of robot import volume, import amount, and introduction volume and operation rate. So these concerns cannot be overlooked. Therefore, it is necessary to explore how the introduction of robots can be a social win-win cooperation rather than a social issue, and what are the alternatives or solutions. And this is about use of industrial robots. Korean manufacturers are really active in introducing robots. And according to MIST, the number of domestic industrial robots is about 320,000 as of 2018. And as for the number of robots per 10,000 manufacturing workers, Korea ranked second after Singapore with 774 units. And this is about 7 to 8 times higher than the global average of 99 units. However, the introduction of such robots has not led to the establishment of smart factory. And according to KDI, there was a report in November in 2019, and the smartization of domestic factories remained at 37 points. And the gap between factories with high level of smartization and the factories with a low level of smartization is increasing day by day. And Korea is showing the highest adoption rate of robots, and according to this report, per 10,000 workers, the number of robots, Germany is 300 and Japan is 200 something, and Korea is showing the highly intensive robot adoption, and in some manufacturing sector the percentage is higher. And in case of Korea's automotive industry, per 10,000 workers, more than 2,500 robots are being used, and the number is at least twice higher compared with advanced countries. And this number is around 4.5 times higher than that of the US. And this is about industrial robot supply estimates. And robot-related industries are developing really fast, and this is high value-added industry. And regarding manufacturing and distribution of robots, I believe that Korea needs to respond to this market landscape. So to facilitate robot industry is very important to increase competitiveness, and it can be a good opportunity to preempt new opportunities. So this is domestic production and import-export statistics related to robots. And in the recent years, with the progress of industrial advance in Korea, the demand for a small number of high value-added robots is increasing rather than the introduction of several simple robots. And the amount of introduction continues to increase. And this is mainly related to introduction of high value-added robots, and the proportion of imported robots increased until 2014 and decreased until 2016, but increased sharply again in 2017. And overall, about 30 to 40% of robots installed in Korea are imported. And when importing robots, they have to be purchased at high prices, and which can lead to job losses in domestic industries. Because robot manufacturing industry in Korea, when the industry has not been developed, and when we import the robots, we cannot achieve circular economy. And on the other hand, in case of domestic production, it can be purchased at a lower price than imported products. And it can facilitate robot industry in Korea and jobs can be created. So we have to adopt robot to manufacturing process, but we have to make sure that we can manufacture robots, then we can achieve circular economy when it comes to job creation. And this is statistics on the number of robots introduced by sector in the manufacturing industry. And when it comes to robot density, Korea ranks really high in the world. But the robot adoption is being concentrated in some industries like electronic industry and automotive industry. These industries are showing very high intensity in robot adoption, but other industries are still showing very low robot adoption ratio. And robot hardware and software manufacturing, Korea still does not have national competitiveness. So therefore, we have to facilitate robot adoption. By doing so, we can create quality jobs and we can nurture robot industries to enhance competitiveness of robot industry. So we have to nurture robot supplying companies. So now let me talk about supply side of robots. The effect of revitalization of the robot industry in the robot supply industry is that the size of the robot industry itself grows and the import of domestic robot demand, which is increasing, is replaced with domestic products. An industry that can grow as the size of the robot industry itself grows include the robot manufacturing industry and SI company and system operation industry. And these industries can naturally grow in size and increase sales as the demand for robots increase, and that can result in increased employment. And revitalization of the robot industry has an import substitution effect in the field of robot supply. So as part of the revitalization industry, we have to develop robot manufacturing companies in Korea, and we need to come up with lots of policies to develop manufacturers. So now let me talk about some concerns regarding loss of jobs. By vitalizing robot industry, there can be some job losses, so let me touch upon that. And currently, in the case of direct production of domestic demand in Korea, there are many cases of simple robots, low value-added robots, or recently, mid-value-added robots. But the reality is that many high value-added industrial robots rely on imports. So if imports of these mid-value and high value-added robots can be produced by domestic companies through revitalization of the robot industry, it can cause import substitution effects. So it cannot lead to circular economy of Korea. So if we make an environment where domestic companies can manufacture this mid-value and high-value-added robots, we can create more jobs. By doing so, we can develop robotic industry in Korea, and at the same time, we can create more jobs. By doing so, we can avoid the job loss problem. So at this moment, we are producing low value-added robots, but we import mid-value and high-value-added robots. That means that we have to pay a lot of money for imports, and they are imported robots that can cause job losses. And even though people lose their jobs, they cannot find jobs in other industries. And if we change this situation, and if we do not import, rather if we develop mid value and high value added robots domestically, I think we can address this problem. So because of that, we have to avoid the situation where we continue to import high value added robots. So now let me talk about robot product preference by nation. And according to statistics by Ministry of Employment and Labor, the preference for domestic robots is the highest. In low value added, medium value added, and for high value added robots, for three categories, Korean people prefer domestic robots. And the preference ratio was 52% of SME enterprises using robots, and 53% of SME, and 50% of medium-sized enterprises that do not use robots, and 96% of SME that do not use robots. And following domestic brand, there was high preference for Japanese and German products. So once again, domestic robots are ranked first. That was followed by Japanese and German products. And preference for imported brands was 32% of SME using robots, and 27% of SMEs using robots, and 25% of medium-sized enterprises that do not use robots, and 0% of SMEs that do not use robots. This was the preference ratio for Japanese brand. And as for the preference for German products, the preference ratio was 14% of SMEs using robots, and 52% of medium-sized companies, and 25% of medium-sized enterprises that do not use robots, and 4% of SMEs that do not use robots. And this is about industrial robot risk assessments. There are 4 items as you can see in this slide. First item is determining the limitations of robotic system, and second is about identifying hazard, and third criteria is risk calculation, and lastly this is about risk determination. So when it comes to industrial robot as well, it inherently has risks, so we have to assess the risks. And now let me talk about how new technologies and new ways of working and social changes can affect workplace safety and health. We call it ICT, or Information and Communication Technology. And this is about impact of ICT development on workplace safety and health. And in terms of safety and health, the most important benefit of development of ICT is to free people from harmful environments. And by doing so, it can provide new opportunities for communication beneficial to workplace safety and health. That is one of the biggest benefits of ICT development. And in Korea, 1,957 workers died from industrial accidents, and among them, 964 people died from accidents. And the number of accidents per 10,000 workers, which we call as accident death ratio, and the ratio was 2 to 3 times higher than that of the advanced countries like Germany. And the government is recognizing severity of this problem. So the government announced that it would reduce the number of deaths from industrial accidents, suicide, and traffic accidents by half by 2022. And there was a tripartite representative meeting, and it was agreed at the meeting to establish an affiliated group to come up with innovative measures to prevent industrial accidents. And OSH Committee for Safe and Healthy Workplace was established and is being operated. So let me talk about this OSH Committee. And it will eliminate blind spots of OSH, and it will secure the effectiveness of OSH, and it will improve the supervision and administrative system of OSH. And there are soft committee meetings, and they talk about agenda, and they are talking about platform workers and emotional laborers and death from overwork and suicide from overwork. So this kind of safety and health issues are being discussed in this committee. And these are occurring due to changes in the working environment due to the recent rapid technology development and changes in the industrial structures. So this is a social awareness and consensus on the need to discuss new safety and health issues and prepare countermeasures due to rapid changes in the working environment in Korea. Then, in the manufacturing sector, how can we facilitate the introduction of robots? So you may have some ideas for that revitalization. So to facilitate the robot adoption, first of all, I think that the priority should be changed. The priority still is on the simple and repetitive tasks. And because of that, they can lead to job losses. Of course, the profitability of companies can go up, but there can be strong opposition from unions. So, first of all, to adopt robots into manufacturing sector, rather than applying robots to simple repetitive tasks, we have to first apply robots to risky operation. So we have to introduce robots to the most dangerous tasks rather than simple tasks. If we apply robots to simple tasks, it can cause social issues. And to avoid job losses, we have to apply robots to the most dangerous tasks. And we have to deal with the opposition from union through negotiation or compromise. And if there is too much opposition from union, they may withdraw the introduction of robots. So for this end, we have to apply robots to the most dangerous tasks. By doing so, we can secure safety at the site. At the same time, we can persuade a union to introduce robots. So once again, rather than simple tasks, we have to put priority on the most dangerous tasks. By doing so, we can facilitate robot adoption in the manufacturing sector. And secondly, rather than importing robots, we have to develop robot industry in Korea. To facilitate robot manufacturing industry, we have to make efforts. By doing so, we can increase national competitiveness and we can lead this industry in the future. But at this moment, we have to import lots of robots. So against this backdrop, it will be difficult to manufacture robots domestically. So if we nurture robot manufacturing industry in Korea, we can create import substitution effects. And at the same time, there is a need to create high quality jobs. So once again, rather than importing robots, we have to manufacture robots in Korea. By doing so, we can reduce the unit price and we can revitalize domestic robot industry. So to summarize, my second proposal, rather than importing, we have to develop robot manufacturing companies in Korea. So this is a third proposal to revitalize robot introduction. Well, imported robots are expensive and there is opposition from the union. And even though you introduce robots, there are many cases with safety concerns and issues, so it's important to strengthen safety of robot itself. And even for this, if we manufacture domestically rather than importing robots, if there is a safety issue, it will be very easy to reach and approach the domestic manufacturer to talk about problems. But if we import, it will be very difficult to communicate or get technical support. So we have to strengthen the safety of the robots, and there is a risk of malfunctioning and misoperation of the robots, and these problems are inherent in the robot use. So to address these issues, regular risk assessment should be carried out. And for that end, we have to formulate safety plan and we have to implement the plan. And for that end, continuous efforts are required to improve the safety of robot itself. And when the robot safety is strengthened, the introduction of robots into the manufacturing sector will be facilitated. And this is the last proposal. We have to clarify the purpose of introducing robots. Rather than simply copying others, we have to think about why we are introducing robots. So we have to clarify the purpose of introducing robots, and we have some checklists. They are what, where, and why. There are 3 important checklists. Where means in which site are we going to use, and what means what kind of industrial robots are we going to use to increase automation. But we have to move beyond automation to smartization. So now it's time to think about why. So why has become more important than anything else. So why are you trying to introduce a robot? We have to clarify the purpose of introducing a robot. So what kind of purpose and result are we going to utilize a robot? So rather than using a robot for simple, repetitive tasks, we have to think about a purpose. Otherwise, there will be job loss problem in Korea. So once again, we have to think about the purpose of and result of robot utilization. And depending on the solution, we can introduce a new robot, or we can upgrade or modify existing robots. So once again, why is very important. I want to highlight once again, rather than introducing robots to simple repetitive tasks, we have to adapt robots to the most dangerous tasks. By doing so, we can promote robot industry in Korea. And as for the robot manufacturing companies, they can go beyond low value added sector. They can move toward mid value and high value added sectors, when we can avoid job loss problems and we can reduce the price of robots. And I believe these are measures to facilitate robot adoption into the manufacturing sector in Korea. This concludes my presentation. Thank you very much.
네, 강연 잘 들었습니다.
Yes, thank you. The panel discussion that was scheduled to be held would not be available. So with that, we'd like to conclude today's program. Thank you very much. And if you have any comments or questions, please email us and we will try to provide you with the answers as best as we can. Thank you.